Hi Math 111. So this is our first video for section 1.2, and in this video we're going to be talking about finding intercepts, both using algebra and using our graphing calculator, and about a few specific graphs that are going to be important for us to know for the rest of the term. We're going to begin building a library of functions, a library of graphs really, and we're going to start that in this section. So let's first think about how we can find some intercepts. And if you remember from the last video from section 1.1, we were talking about X and Y intercepts, and we were working with an example, right? And I think let's just recall what that example looks like for a second. It was, we were working with the equation 3x minus 12y equals 6. Right. Oops, and that's not quite right. It was 3x squared, right? Remember, it ended up being a parabola, right? It might actually still be stored in my calculator. We'll see. So remember, we used our calculator to be able to graph this thing, and remember, it ended up being a parabola, right? It wasn't a line. It was a curve, a very specific kind of a curve. It was a parabola. And let's just again see how we solved for y in this case. Remember, we moved the 3x squared over with the 6, and so we got negative 12y equals 6 minus 3x squared. And then we divided both sides by negative 12 to get y equals 6 minus 3x squared all over negative 12. Remember, and we were able to enter this into our graphing calculator. So let's look and see if it's still there for us. Yep, there it is. Remember, I had zoomed in on here to be able to see the X and Y intercepts a little bit more clearly here. So let's actually just remember for a second what we mean by intercepts and how we define them. So let's see. So what we say is that the points, if there are any, at which a graph crosses or touches the coordinate axes, the xy axes, those are called the intercepts, right? So where it intersects, right, those are called intercepts, right? Words are sort of similar. And specifically, we like to identify the x-intercept versus the y-intercept, right? They are different things. So the x-coordinate at which the graph crosses or touches the x-axis is an x-intercept. A graph can have more than one x-intercept, right? It might have many, okay? Alternatively, the y-coordinate or the y-value, right, at which the graph crosses or touches the y-axis is called the y-intercept, right? A graph can only have one of these if it's a graph of a function, and you'll see why in a later section, but there should only be one of those, right? And note here's some alternative terminology for you that sometimes we call x-intercepts a variety of things, right? And they're all synonymous, right? So x-intercepts can also be called solutions of an equation or root or zero, right? So any of those words are sort of interchangeable, right? X-intercept, solution, root, or zero, right? Any of those words. And some of those words will be used heavily with our graphing calculators. Okay, so let's go back to our graph for a second on our calculator here. So again, remember we entered this by plugging in this 6 minus 3x squared parentheses closed to indicate numerator, divided by negative 12. Okay, I didn't have to put parentheses around the negative 12 because that's just a number, right? It's not like the 2a we had with the quadratic formula where there was two things down there. This is just one number. It's just one thing down there. So we don't need parentheses. But you of course can put them there if you like, just to be cautious. So we've entered it here, and again we hit graph to be able to see what the picture is. Yours might look not as zoomed in because it might be in the standard viewing window. To see what the standard viewing window looks like, you can hit zoom, and then you can go to zoom standard here at 6. You can just hit 6, or you can arrow down and hit enter. I'm just going to hit 6. And that's going to take us, a standard window is 10 by 10 in terms of dimensions here, right? And again, it's kind of hard for us to see what's going on there. So I'd like to zoom in closer. So I can zoom, and then option 2 is zoom in. Okay, and it's asking, it's sort of waiting, it's blinking, right? Because it's waiting for me to say where I want to zoom into. So hit enter because it's already at the origin. If you wanted to zoom in someplace else, you could arrow left or right and then zoom in someplace else. Okay, but here we've zoomed in closer towards the origin. We can see these x and y intercepts here now. Okay, so we can do a couple of things here. we can find the x and y intercepts of this equation graphically using our calculator, and we can also find them algebraically. So let's first find them graphically, just so we can see how powerful this calculator really is, right? So if I hit the trace button here, right, you'll see that if I hit trace, there's a little blinking cursor. The trace button always gives you ordered pairs that are living on the graph. And remember, what that means is that the ordered pair it gives you here, right, is an ordered pair that is on the graph, which means that ordered pair satisfies the equation, right? When you plug in x equals 0 and y equals negative 0.5, it'll make this equation true. And we talked about that in one of our other videos. So notice here that it's already blinking right on the y-axis, right? And notice that the ordered pair is 0, negative a half. Okay, well remember that points living on the y-axis are always of the form what? Nothing and then a number, because you just go what? You go up or down something, right? You don't go left or right. So that point right there, that's our y-intercept, right? So we could actually go ahead and notate that down for ourselves. So our y-intercept, okay, some books like to see just the y-intercept written as just the y-coordinate. I think it's kind of nice to write it as a full ordered pair, just because then you're aware that it's a point in the xy plane. So it's the ordered pair 0, negative 0.5. And I'm going to write that as negative 0.5, so you can see the dot, just in case the dot's kind of hard to see. Okay, so that's our y-intercept. So how can we go about finding the x-intercept? Well, notice there's two of them, right? So your calculator can actually find this for you. If you wanted to just move along on the curve, you could hit left or right, and notice that your cursor sort of moves along the curve. If you tried just getting close to that x-intercept, oh, we went past it, right? We can't get exactly on it, right? Because that x-intercept is going to happen where what? Y is equal to 0, okay? Where y is equal to 0 here, okay? So we don't know what the x value is so that y is equal to 0 and we're on the graph. Well, your calculator can do that for you, so let me clear my key presses for you so you can see exactly what I'm going to do. So in this calc menu right here above trace, there's actually an option so that you can find out what the x-intercept is. So let's hit second calc, right, second trace. Notice that the second option here is 0, right? And remember I told you one of those synonymous words for x-intercept is 0. So let's hit number 2 to pick that. Now what it's going to ask us to do is give us a little neighborhood in which to find the x-intercept, because it doesn't know which one we want to find, right? So you have to give it sort of a reference, a little frame of reference here. So make sure that your little cursor is just to the left of the x-intercept. Hit enter. And then move your little cursor over so that your little blinking light here, your little trace thing, is to the right of the x-intercept. Notice it says right bound. Okay, so be on the right side. And then it says this cheeky little thing where it says, where do you think it is? And it says guess. It doesn't really matter. You can try to get close if you want to, or you could just hit the enter button. Okay. So now we can see that the exact 0 is happening. Well, we can't say exactly because this is actually an approximation, but we can say that this x-intercept is happening at, and we can just maybe use the first 3 decimal places, 1.414, comma 0, right? That's one x-intercept. There's also another, right? I'll let you find that other one on your own, but I will tell you that it will be, so you can check your answer, negative 1.414. Comma 0. And you might be able to see why, right? The graph looks pretty much the same on each side. So if you have to go over that far to get to this point, you probably have to go over that far the same way. But I'll let you try that using the techniques we just did with the second trace, second calc, to get that calc to do the 0, right? You try it for the other one. Okay, so let's actually see if we could figure out these intercepts algebraically here. Okay, let's get a new sheet. Okay, so let's find the intercepts algebraically for this same exact equation, right? So we had 3x squared minus 12y equals 6, right? So how exactly do we find x and y intercepts algebraically? Well, let's see. I bet I probably have it written down for you. Yep. We can find them graphically or algebraically, and here I've outlined how to find them algebraically, okay? So remember that for an x-intercept, that's what? Let's look at our graph for a second. See if I can highlight. Oh, I just closed it, darn it. Okay, that's okay. So For an x-intercept, remember that's where it hits the x-axis, right? And that's where points on that x-axis always have the y-coordinate being 0. So to find it algebraically, let's let y be 0 and figure out what the x is going to be, right? So we need to figure out when y is 0, what is the x on that graph. Alternatively, to find a y-intercept, remember that's where it hits the y-axis, and points on there always have what? The x-coordinate being 0. You don't move anywhere left or right. So in the equation we'll say, well, let the x be 0 and figure out what the y's got to be. Okay, and let's do that for each one of those for this equation right here. So let's find the y-intercept, just for fun, and I'll abbreviate that y-intercept, int. So for the y-intercept, what do? We let x be 0. Okay, so let x equal 0. So that means we do 3 times 0 squared minus 12y equals 6. Okay, this is all 0 over here, right? Because 3 times 0 is 0, so that's gone. So this is just negative 12y equals 6. And we divide both sides by negative 12 to get y equals, 6 over negative 12, which is, if you remember, this is what? Negative 1/2. Well, that's interesting. So doesn't that mean our y-intercept, remember y-intercept points on the y-axis, the x is always 0, and then we get a number. So the y-intercept is in fact, and actually let's do this in a different color so you can see I didn't get it first. We'll do it in, how about, yeah, the red is pretty sweet. Okay, we'll do it. So the x part was 0, and the y-coordinate was negative 1/2. That should look familiar, right? If we go back one page, our y-intercept was, we found it graphically 0, negative 1/2, right? That's exactly the same thing. Okay, so the graphical and algebraic methods are equivalent, right? You can do either one. All right, so let's now find, second thing to do, we got to find our y-intercepts. Okay, so, oh, we already did y. We got to do x-intercepts. Here we go. So let's find the x-intercepts. For x-intercepts, what we've got to do? Let y be 0. Okay, so we do 3x squared minus 12 times 0 equals 6. Okay, again, that thing's 0, so we just get 3x squared equals 6. Divide by 3, we get x squared equals 2. And when you have x squared equal 2, what happens? You get 2 answers when you do a square root, right? You get x. If x squared equals 2, then x has to equal what? Plus or minus, my plus was bad, plus or minus, and it would be what? The square root of 2. Okay, that's interesting. We get 2 answers. And this is our x-intercept, remember? So that means that we have what? We have our ordered pair would say it's on the x-axis, so x values and then nothing for y. So we would have what? We would have the square root of 2 and then nothing for y, but this one tells us we have 2 answers. So we also have negative square root of 2, comma 0, and those should have been pink to match the other ones, but that's okay. Well, is that okay to have 2 of them? Well, if you think back to what our graph looked like, remember I closed our calculator, sorry about that, but our graph looked something like this, right? It had one y-intercept right there and it had 2 x-intercepts. So it makes sense that there were 2. And if we look back on our other page here for a second, notice we got 2. 1.414, 0, and then I told you, and hopefully you confirmed, that the other one was negative 1.414, comma 0. Actually, those decimals right there are approximately the square root of 2. And your calculator can only approximate. It can never give you an exact answer, right? It's really kind of tough about that because your calculator is always running sort of an approximation process. It's never doing like this kind of process that we just did where we're doing algebra, right? It's always sort of approximating using an algorithm. Okay, well, we've found the x and y intercepts algebraically and graphically. So what we can do is stop with this video for right now, and in the next video for section 1.2 we'll talk about those graphs that are going to be important for us for the rest of the term. On to the next video.